All right, I've started recording. Welcome, everyone. I'm so glad that you can join us for today's Manufacturers Roundtable on all electric commercial kitchens. This roundtable is a collaborative effort between CEDA, PG&E, NBI, and AWHI. My name is Susan Harris, and I'm the Senior Communications Specialist with New Buildings Institute. I will be your moderator today, and Joe Wachunas, NBI Senior Project Manager, is also on hand to provide support. Our goal with these events is to bring you leaders in electrification to answer your questions and discuss why this movement is important, where there are challenges, and how, through electrification, we can do things better. We have a panel of experts with us today to talk about all electric commercial kitchens, combination ovens, induction cooktops, and water heating. Comments or questions for other attendees can be put under the chat, as I'm seeing people starting to chat now. So nice to see people mentioning where they're at. Feel free to join in and tell us where you're tuning in from today. If you have a question for one of our panelists, please put that into the Q&A section. And our event is planned for an hour today, but if there are lots of questions, then we'll add an extra 15 minutes at the end so that we can try to get through all of those questions. As I said, we'll be recording this event. I'll send out an email later on so that you can have a link to the recording as well as slides. We'll also include some of the links that we'll be referring to during our discussion today. We greatly appreciate the support from CEDA. And before we dive into our content, we'll hear more about this important decarbonization program from Sean Williams, Outreach Specialist, who is here to talk with us about the CEDA program. Oops.
Hello all. Hope everyone is having a great day out there. Just wanted to spend a couple moments here discussing the CEDA program, which is the California Energy Design Assistance Program. The program is the only statewide utility program, incentive program for new construction and major renovation projects. The goal of the program is to promote electrification when possible and decarbonization. And the program aligns with California's broader decarbonization goals as well. So CEDA, it does work in collaboration with the project team to help reduce energy demand, consumption, and carbon emissions. Within the program, we do serve commercial, public, high-rise, multifamily, 4-story or higher, industrial, and agriculture projects located in either the PG&E, SoCal Edison, SoCal Gas, or San Diego Gas and Electric service territory. It's worth noting that PG&E is the program administrator, with the other investor-owned utilities participating, and Willdan serving as the program implementer. So why participate in CEDA? So some of the key benefits of participating in CEDA here, you will receive on a per project basis, a custom complementary decarbonization analysis that is tailored to the project goals to help the team identify the most effective energy efficiency strategy to implement. It is also a great opportunity to gain analysis of energy costs and payback structures, receive financial incentives to help offset the cost of implementing decarbonization measures. And of course, demonstrating the commitment to high performance building practices and design. So through the program, we do offer building owner incentives, but there is also a additional incentive that is a $2,800 design team incentive per project to offset, any time spent for participation. So the design team incentive, it's a flat $2,800 for participation in 2 live meetings, which totals about an hour and a half worth of time. Now, the measure package incentive is based off the project measure package that the design team chooses to implement. And with that, we will, go over various strategies to help the team land on the best targeted strategy. Okay, and just a moment here talking about high performance measures. So CEDA does aim to exceed California's decarbonization standards by identifying high performance measures and providing educational opportunities to explore use cases and best practices. It not only advances the market, but also qualifies participants for enhanced incentives through the program. And on our website here, you can take a look and see a list of eligible high performance measures, such as high efficiency lighting, high efficiency elevators. There's a ton of different high performance incentives out there that you could view directly on our website. So right here, if you guys want to take a minute to scan the code and just jot down my information. Once again, Sean Williams. I do outreach for the Wilden and the CEDA program. Would love to discuss any potential projects further and kind of give you a more detailed description of how the program might work and to help the team determine if there's any benefit in having your projects enrolled into the program.
Great, thank you so much for that, Sean. And Sean, would you please put in the chat a link to where people can access more information about the program? There was
Absolutely.
a point on the slide that says you can find more resources here, and I think that could be a good link to provide in our chat.
Absolutely. I will provide a link in the chat.
Thank you.
Thank you.
Well, some people might ask the question, why all electric commercial kitchens? And well, we may know that there's a lot of reasons. Commercial kitchens and their gas-fired appliances are a good place to start while we try to eliminate greenhouse gas emissions. According to Energy Star, restaurants use roughly 5 to 7 times the energy per square foot as other commercial buildings. And this amount can be even higher in high volume, quick service restaurants. Meeting goals to reduce greenhouse emissions, conserve natural resources, and protect the environment require us to take action. There is a silver lining though. While using efficient electric equipment and meeting those goals, there are added benefits, including faster cook times, better work conditions, and improved air quality, all while making the same delicious food. So today we'll talk more. Why are a growing number of kitchens embracing electric equipment? What are the barriers and solutions? And some examples of the latest electric equipment for commercial kitchens. Some of you may have joined us last year when we spoke to Chef Christopher Galarza along with Richard Young, who's here with us today. Today we're going to focus in on the equipment. We're going to talk about combination ovens, induction cooktops, and heat pump water heating equipment. And these are our panelists for today in order that they'll be speaking with us. First up, we have Richard Young with Frontier Energy Food Service Technology Center, an unbiased commercial food service research and training facility. And then we'll have Lee Baker, Vice President, Product Management for Rationale USA. Their products include the iVario Pro, a multifunctional cooking appliance for professional kitchens. Then Kurt Eichmeyer will speak with us. He's Senior Vice President, Strategic Initiatives for Jade Range and Beach Ovens. Their products include a state-of-the-art induction wok. And then last but not least, Michael Slater will talk to us. He is the research engineer for Frontier Energy, and he focuses on decarbonizing technologies related to hot water systems for the food service industry. And with that, Richard, please tell us more about commercial kitchens.
Great. Hey, everybody. And I'm just going to request control of the slides real quick. See if I can make these go so I can annotate. and I'm going to give you a really quick, like 10-minute overview and then some resources. And then I'll go offline and spend some time like answering all your questions. So we'll have some fun today. And let's see if I've got control. There we go. All right. Main challenge for all electric kitchens. You know, we tend to think, oh, is it behavior change, whatever. Really, the main challenge is that electricity is a more expensive fuel than natural gas. As from our vantage point, that is the number one thing that we see as a challenge to all operators out there, because food service is a narrow margin business. Nobody ever has enough money in food service. So having said that, can we get this slide to change? Come on, slide. I know you'll do it for me. There we go. Big reality. I'm going to say this twice in this presentation. Energy efficiency is the most crucial component of decarbonization and electrification. Energy efficiency, okay? Super important to remember that. And can we get it to change? There we go. So the pathway, what are we going to do? Well, we still to this day are building kitchens that are kind of based on a 1940s, just post-World War II model of a lot of equipment, big kitchens, big hoods. The pathway is that we're going to move to the electric kitchen of the future, which will be smaller size. You can do more with less labor. We will use high efficiency, programmable, high-tech equipment. And this kitchen of the future is going to be fast, small, flexible, and super efficient, because energy efficiency is a super important part of what we're going to do here. And come on, change for me. Susan, now I'm thinking I should have let you do the slides.
We can change anytime.
In fact, that's what we're going to do. We're going to go back. I'm going to give up remote control, and you should have those again. Yeah, it's just moving too slow for us. It'll take us all day to get through. So performance, this is one of those big things. Oh, Richard, chef says that if I put in gas equipment, he'll quit. He did, because that electric equipment won't work. So there's always this question, can electric equipment keep up? Susan, advance one there, click it one more time. And the answer is yes, and hit the advance one more time for me. So what we did was, at the Food Service Technology Center, we've spent the last 37 years testing thousands of pieces of equipment. So here's an answer. If we look at the chart I have here, you'll notice across the bottom, I have 1, 2, 3, 4, 5 different kinds of major appliances: griddles, fryers, convection ovens, combi steamers. The blue bars are the gas, the red bars are electricity. And what we're showing here is pounds per hour of food cooked. And you can see that in every case, griddles, fryers, convection ovens, combi ovens, steamers, the electric equipment keeps up with the gas equipment. Now, what I'm comparing is quality, high efficiency equipment, right? But across the board, if you're buying decent equipment, and in fact, in the combi oven world, which I think Lee might talk about a little bit, combis actually have a little bit higher production rate than the gas equipment. So yes, get that out of your mind, that electric does not perform. Electric equipment keeps up with gas equipment, performs beautifully. Next slide, please, Susan. So we're going to do something real fun here. We're going to model 4 configurations of a small kitchen. And this is based on a chef that we actually worked with as he designed his facility. He came into our lab at the Food Service Technology Center, worked with our consulting chef, and we figured out the best kitchen for him. And then we decided, hey, let's model this all out, and let's see what would have happened if he'd made this choice and that choice and this choice. So here's the 4 things we're looking at. A base efficiency kitchen, which is gas and electric; a high efficiency kitchen, gas and electric; a kitchen of the future where we got an optimized, fast, small, flexible cook line. This one is still going to include both gas and electric. And then we'll say, what if the chef went all electric? And my assumptions are based on PG&E numbers, about $1.85 a therm, 34 cents a kilowatt hour, and PG&E carbon rates, which are really, really low. Thumbs up to PG&E. So let's go to the next slide, and let's look at the very first example. If the chef just went down to the restaurant supply store and said, give me some stuff, he'd probably come back with some relatively low cost, very low efficiency, base efficiency cook line, right? And in this case, a couple, 3 ovens, a standard griddle, a range top, a stock pot range, a steamer, and a hot food holding cabinet. And that little small kitchen running a normal service, lunch and dinner, would spew out about 35 metric tons per year of CO2 and cost that chef about almost $25,000 to operate. Okay, so that's what is really happening every day, all day, right now. That's the design and the emissions that we're seeing out of a typical small cook line. Let's go to the next slide. Now, on this next slide, let's suppose chef had heard about our California Energy Wise program, or had talked to somebody at the Food Service Technology Center and had actually taken advantage of the rebates and simply moved up to efficient equipment. Same cook line, but just the most efficient versions of all of that stuff. What we've got here now is that we have reduced both our carbon output and our cost to operate by 1/3. Okay, we cut 10 tons and $8,000 simply by going with efficient equipment. So one big important thing I want to point out to everybody on this call, if you have an existing kitchen and you do not currently have the opportunity to go all electric, you cannot remodel panels, whatever, moving to efficient gas appliances is a very effective, right now, cost-effective way to reduce carbon. So do not take that off your menu. High efficiency gas appliances are very effective way to reduce carbon right now. But that's not what we're talking about today. We're talking about the kitchen of the future. So let's go to the next slide, Susan. And in the next slide, what we've got is our the work that we did with the chef. So we looked at his cook line and we said, hey, let's move to some cool things. So starting from left to right, we put in a small half-size rack oven, a combination oven, which Lee's going to talk about, a pasta cooker, induction cooktop, which Kurt's going to talk about, a super high efficiency griddle, and a rapid cook oven. This is our kitchen of the future. Next slide, Susan. Okay, so now we have a hybrid kitchen of the future. We still have some gas appliances. The ovens, pasta cooker, griddle are gas. Induction rapid cook is electric, but look, now we're down to 12.5 metric tons. We've cut 2/3 of the carbon off. We've also cut the fuel cost by 2/3, right? So the chef went from almost $25,000 to right around $8,000. Huge savings, huge payback. Now this equipment up front takes some cost and some time to do the design, to design your kitchen of the future. And this is now high-tech quality equipment, but it's also programmable, easy to clean, all of these other things. So that's where the chef, that's what he chose. That he's a small business operator. That made the most economic sense. But on our next slide, Susan, if the chef had said, I want to go all electric, let's say the chef was right now in San Francisco opening up a new restaurant, would be required by municipal code to go all electric. Absolutely could have done that, gone all electric. Now we're down to 2.2 metric tons of carbon. Our cost to operate does go up a little bit because electricity is a more expensive fuel than natural gas, but because of our good design, the all-electric kitchen still costs less than the base efficiency. And let's look at that in the final slide to sum all of this stuff up. So what we got here is our base efficiency kitchen is the blue line. And if you look over to the left, you can see that's almost $25,000. High efficiency, just a little more than $15,000. Our hybrid kitchen of the future is the purple bar. Now we're down into right around 8,000. Our all-electric kitchen of the future is going back up to about $18,000, but it still costs you less than that blue bar, the base efficiency kitchen. And the nice line that you see going from the upper left to the lower right, that is our carbon reduction. And if the restaurant was right here in my neighborhood in Oakland, where I buy completely clean energy, we could take that carbon all the way to zero. So there's a great story right there in that slide for you. But once again, big point requires energy efficiency and design. Let's go to the next slide and talk some resources. And next slide after that. So great big giant resource, California Energy Wise program. If you were in California, then we can do energy surveys of your facilities. You can work with us to come in and try out equipment. There are California rebates. I'll talk about that in a minute. But Chef Andrew had also asked, hey, I'm in Denver. What happens when I'm in Denver? Well, we have seminars, we have design guides. You know, we're not stingy with this information. And we know that people also, designers, manufacturers, work across borders. So we make as much of this stuff available to everybody as possible. caenergywise.com. You don't have to log in. You don't need a membership. Go try it out. If you have projects outside of California, contact us. We'll try to help you in some way or hook you up with resources. If you're in California, contact us because we also have design resources and consultations in California. Let's go to the next slide, which should be the California Instant Rebates slide. Yes. So once again, from the caenergywise.com site, these instant food service rebates are available throughout the state of California for the IOU utilities. You buy a piece of equipment, if it qualifies, the rebate is instant on the right on the invoice. And in the next slide, very exciting, we have just introduced induction cooktop rebates, $250 per hob. So a 4-hob unit, $1,000 in savings. Brand new, very easy to get. 10 different manufacturers, 63 models, go for it. And once again, if you have any questions, you let us know. And next slide. Also, if you were in PG&E territory and you would like to try an induction cooktop, we have an all expense paid 2-week loaner for you. We pay all the shipping, we pay everything. You get a kit. There's a QR code. You're also getting these as handouts, so you can grab that QR code now, or you can get that in the handouts. Please take advantage of this. It's a great program, and we're getting a lot of positive response. It's your chance to take it home and play with it. Next slide, please. And this is my final wrap it all up reality. Energy efficiency is the most crucial component of decarbonization and electrification. Do not try to electrify your kitchen if you do not do some design and some energy efficiency. Your bill will go up. People may not be happy. You may not get what you want out of it. Use energy efficiency, but if you do, it's all there. And I believe that's my last slide.
Thank you so much, Richard. We
Thanks.
had one question that we thought we might pose
Yeah.
to you before we move on to our next panelist. Someone asked, as we go through these scenarios, could we let them know if the upfront cost assumptions calculations include the cost of kitchen electrical work based on the capacity of an average kitchen?
Yeah. So the electrical work is a really interesting question, and one of the so I got two answers for you. One, there is a CalNext study that you can look at that just kind of mocked it out on a few different levels, operating cost and panel cost. So we have kind of a 10,000 foot view of that. And yes, operating cost can go up and panel cost is there. But once again, if we focus down on individual facilities, in some cases, you may have enough panel size. You may be a big university or a high-tech building, something like that. If you're a small operator, you may not have panel size. The panel size and the upsizing of panels in existing facilities is a real challenge. In new facilities, of course, much easier to do a single, just one thing, electricity in the building, not mix your services, and size your panel up right. But I can't give you just a rule of thumb because it's all over the place, and we're still all trying to get a handle around what the panel is and infrastructure stuff is truly going to cost us. Very good question, and thank you.
Thank you, Richard. And then next we have Lee Baker from Rationale USA. Lee, please talk to us more about combination ovens.
Thank you so much. Thank you for joining today as well. If you could advance to the first slide, that would be great. And just continuing on the electric topic, as Richard was stating, electric appliances, they really help to pinpoint and control energy where it needs to go. This is the biggest difference between gas appliances and electric designs. So in this electric design, you have heating plates that are directly under a pan base, and it allows you to really heat quickly every square inch of that pan base, which really eliminates hot spots and cold spots because you don't have a gas that is kind of just firing in a direction to heat a product or heat a pan base. It's, of course, a massive reduction in CO2 emissions, and there is a significant increase in recovery time and precision. So when we look at kitchens that are doing roughly 750 meals in a day or during a meal period, this is about a 73% energy savings in usage because you do not have all that wasted energy going essentially into the air and heating kitchens. It also is about 55% time reduction in time of production. That's part of the benefit, but another major benefit, which I think people don't always take into consideration, is really the size of the equipment. So energy equipment or electric equipment typically has a much smaller footprint than gas equipment based on the components that are needed for having those gas pipes and flues and so on installed in the equipment. So it's a really precise and great way for recovery time to be shortened by having that pinpointed electric energy directly to a pan base. Next slide, please. This is an example of an electric appliance where we have a 40-gallon electric tilt skillet. And we are able to take 21 gallons of water and bring that water to a boil within 13 minutes. And typically, a gas appliance would take that a little bit longer or a lot longer in some cases, because that gas line or gas energy is not so much pinpointed across the entire pan base. In this example, this is 21 gallons of water. It took 13 minutes to bring to a boil. The pasta is added, And if you go to the next slide, we can see what happens with not only the preheating time, but the recovery time. So now you have pinpointed. So speaking of recovery time, so we're able to take roughly 88 pounds of pasta, preheat the water in 13 minutes, bring that to a rolling boil. And when the product is added, that temperature drop is extremely slight, because remember that electricity is able to pinpoint that heating, the heating elements directly across the entire pan base. And that's only a 7-minute recovery time while that product is cooking, for a total of about 22 minutes. And if you compare this to traditional gas appliances, this is more than half the time in savings for those that have worked in kitchens. But at the same time, it's not producing all of that CO2, and it's not heating that kitchen with all the fire and gas elements that are going into that hood system. Next slide, please. When it comes to the combination oven, so combination oven is dry heat and steam combined. And on the electric units, you're able to, or operators are able to have even an additional hood installed that would collect grease and smoke. But this is a very added benefit, because now you have an electric appliance. You don't have the heating and the CO2 emissions. You have additional space in a kitchen where you may not be able to add extra hoods, which are extremely costly, or have to worry about fire suppression because there is not an open flame. You also don't have to worry about reconstructing historical buildings that in some cases cannot be reconstructed. It has the massive reduction in CO2, as I mentioned. Also, the reduction in air exchange from the hood system by up to 70%. This also can provide it will provide a cooler work environment, and this, especially these days, is attracting more staff that doesn't want to work in those hot, fiery kitchens of days gone by. On top of that, the environment is extremely cooler, and the electric appliances are typically cheaper to purchase. Next slide, please. Lastly, as I mentioned, the combination ovens that are a combination of dry heat and steam, there's also the technology of dry heat, steam, and microwave. This is only available, or has the ability to be produced in an electric appliance. So this is something that, in our opinion, electric appliances are evolving much faster. It gives you more flexibility and, of course, a lot more customer benefits. So we see that also as the kitchens of the future. Thank you very much.
Thank you so much, Lee. Those are some really cool pieces of equipment that you showed us. It was really great to hear you tell us about them. And then next, we have Kurt here to speak with us. Kurt, please tell us more about induction cooktops.
Hello, Susan. Thank you for having us, and I'd be happy to. And I'm just going to keep rolling through slides like nobody's business, so I'll keep Susan busy. We'll talk a little bit about induction, the history of induction really quickly, because I'm a little bit of a tech geek here. I enjoy the facts behind the stories. First, induction demonstration to the world in grand scale was the 1893 Columbian Exposition in Chicago. Company named Westinghouse and a guy named Nikola Tesla was involved in that. You might have seen or heard of him. And in 1933 at Chicago's World Fair, there actually was some induction cooking being demonstrated. Slide, please. But induction cooking, as we understand it, really wasn't introduced to the mass scale until 1972 with the Westinghouse Cool Top 2. Easy for me to say or not. Next slide, please. But now induction can be for everyone. It can be everywhere as long as you have the power, as Richard said. Whether it's single hobs or single burners, interchangeable terms, or multiple countertop, whether it's ranges of various sizes, all of these things are possible for the induction cooking. Next slide, please. Before we get too deep, I mentioned that I was a geek. I'm a ceramic engineer by training. I love the technology side. So Richard's team was kind enough to pull apart a countertop unit for us all to see what's inside. On the left-hand side, you'll see a coil of wire. In the center of that, pointed out, temperature sensor, so that when the unit is operating, we don't just do something silly. Also in that area is a magnetic sensor to detect whether or not there is something magnetic in proximity to that temperature sensor. And on the right-hand side, you'll see the top, which has a piece of ceramic glass. Next slide, please. So how does induction actually work? Probably a lot more than you'll ever want to know, and you'll never repeat it to anyone else, but I'm going to go for it anyway. You have a high frequency alternating current that goes through that beautiful coil. The current creates or induces induction, a magnetic field. So that magnetic field interacts with the metal, a magnetic or ferritic, I won't get too deep into that, piece of cooking or a pan, and that it induces eddy currents or little quasi vibrations in the metal, which heats the metal, which heats the food. Important thing to keep in mind here is we're not, as Lee was also saying, we're not heating air. We're actually not even heating the glass. We're just heating the cooking vessel, which makes it incredibly efficient. Next slide, please. A little picture of how much fun this can be for somebody who's creative. You cut an induction-friendly pan in half. You throw an egg on one half over the coil, over the ceramic glass. You put an egg on the ceramic glass itself. You'll notice the egg in the pan is cooking. The eddy currents are heating up the metal. And the egg that's on the glass isn't doing anything. As a matter of fact, it's cool to the touch. Next slide, please. So induction can be everywhere, and I said almost for everyone. Induction or electric cooking isn't just induction, but induction can be a part of a lot of kitchens. Whether it's flat tops, we put a big plate of steel over the top of those coils, and you can generate heat into a griddle or a plancha. Next slide. Induction can be integrated into cooking lineups, into other pieces of equipment, with other pieces of equipment, refrigeration, etc. Next slide, please. It can be built into cooking suites. Forgive the background. This is Jade Range's manufacturing facility in Brea, California. But what you'll see is electric equipment and induction that's intermingled with electric pasta cookers and fryers and ovens and salamanders, all sorts of fun things. If you want to go electric and you want to cook, it's possible now. Next slide, please. It can also be used in holding. Think about bain-maries or soup pots. Next slide, please. It can also be used in serving where you can't even see the coils or the glass. In the right image, you'll see that there is a coil that is placed underneath the plywood and a stone, a type of ceramic surface, and the magnetic field will go right through and get to the ferritic or the magnetic pot over the top. Great application. Next slide, please. It can even be used in delivery. Your pizza or all of your meals that are being delivered by all of the services these days, you put a target in the bottom of the bag, you drop the bag into the cradle, the bag heats up, off you go. Induction efficiency and friendliness. Next slide, please. But what I'm really here to talk to you about, in theory, is woks and induction woks. In these photos, you'll see a couple of induction woks. Bit of background, Jade's been building woks for decades, literally, and up until recently, all of our woks had essentially a 100,000 BTU big gas burner underneath the wok. Next slide, please. And then someone at Microsoft and their consultants came to ask us whether or not we could do it electrically. Susan, could you do the video for us, please?
So we lean on our equipment manufacturers to say, hey, we need things like an induction commercial scale wok. The induction wok is 4 times more efficient than a gas wok. The first version we got, our chefs affectionately call the nuclear version because it melted all of the pans. And little by little, over time, we dispelled each and every myth that existed around cooking with electricity being inferior to cooking with gas. Trevor, we've got a little surprise for you. If you want to head over to Chef Jevic, he's got an apron for you, and we're gonna see how you handle the induction wok.
How do you replicate the flame experience when you switch to electric?
Choose your weapon. This or a spoon, doesn't matter. Follow what I do.
I'm just gonna do everything you do. I'm doing the same thing.
Fantastic. Put some oil. Add your egg. There you go. Now you're cooking.
What's next?
You ready?
I'm ready. I'm doing exactly what you're doing.
So the more you bang, the flavor is better. Okay, so let's go. Great job. There you go. See? Now the trick to this is that you don't have the fire, so I pull it out. Okay. Let it rest there. Versus the fire walk, because the fire walk you're typically going, right?
Right.
Here you're not. Onions in.
Onions in.
You're gonna have the rice.
So to mimic that char, the wok has different power settings. From 1 to 10, we actually turn it up a little bit and we leave it alone.
And then you're just gonna let it cook.
Pull it.
I'm gonna turn it down. Right? So now, do you smell the char?
I do.
So, and you see the char.
So that's how you get.
That's
okay.
how you get
All
the
right.
flavor.
This smells good.
It
That's
does.
good.
It's my first go it back. Oh, it's not bad.
It's good.
The question I will now ask is, what would you like to eat? That becomes my new question.
Well done, Susan. Thank you.
You're welcome.
Okay, let's go to the next slide. Well, let me dispel one little thing that you kind of heard or maybe didn't hear is about the first version being a nuclear wok. There were no pans melted, as exciting as, and what a great story that would be. The reality is, and this is a great part of the story of the efficiency of electric cooking in general and induction in particular. When we first put the first induction wok in the kitchen, they were 16 kW per hole. If you do a direct electrical comparison, you say 100,000 BTU burner equals about 29,000 or 29 kW. So we put 16 kW hobs in those spaces. What we found was 16 was still way too fast for the chefs, didn't have the tuning that they wanted, and had way too much speed. So what you saw Trevor Noah cooking on were actually 8 kW hobs. And 8 kW, which is about a quarter of the energy, as was said in the video, will more than make up for the amount of cooking energy needed to equal 100,000 BTUs of gas. Couple other things to notice about the video. Number one, you could hear them. They were talking. They're generally in a wok station, you're moving so much air. It is so loud that it's very hard to hear. Number two, the other thing that you notice is that they're cooking a little bit differently. A lot more stirring, less moving of pans. Because whatever your surface is has to be in contact or in proximity to that ceramic glass, you're going to be cooking right there. But if it is amazing to see people make that transition and still get what is traditionally known as wok hay, the caramelization, the charring that you can get from a gas piece with induction. It can be done. It's being done successfully now. Next slide, please. So before we leave you, because I'm already over my time, and even without the video adventure, probably, few things to take away from induction. Number one, if you put a pot of water on top of a gas burner and that same pot of water on top of an induction burner, what you're going to see is about 35% of the energy is going to get into the water over the gas, and a whole bunch of heat's going to be going in the air, versus about 85% of the energy getting into the water over an induction piece. It's more direct heating and a lot less heat loss. You see a lot higher speed in induction. If you put that induction wok on top and throw some water in there, it's amazing how quickly it boils. The other thing that you're going to see is enhanced uniformity of heating. Because you're applying the heat exactly where you want it, and because you have so much control over it, you can do a lot more precision cooking. Next slide, please. The other thing, and we just touched on it, and Lee also talked about it, because you're not exhausting that heat into the space, you have a lot greater comfort for the operators. And you can use a lot less ventilation air, which means a lot less conditioned air coming back in, which is incredibly beneficial and also makes the cost benefit analysis better. And the induction also allows you to potentially do vent free, which means because you're not burning natural gas or something else, you can filter that air and recirculate it into the space. Next slide, please. One more thing before we go. Just one thing before, never mind, I won't do that. To keep in mind it, and actually Richard's slide showed it very well. We'll generally see that we need less, and actually Lee mentioned as well, you'll need less cooking space and less cooking with induction than with gas. We find it's pretty common for people who are using 6 burners to maybe be able to go down to 4 induction burners because of the speed, because of you don't have to use the gas to preheat. The other thing that is a benefit and something to consider, and Richard showed it in his slide, we tend to prefer having 4 individual burners with individual pieces of glass rather than having, as I show in the photo on the right-hand side, the 4-burner range. The reason for that is accidents happen. The last thing you want is for your guys to be coming in overnight, drop a filter hood on top of the ceramic glass, which is very durable, but it can be broken, cracking the glass and making it so you can't use your entire top. If something happens with the electric or with the induction, if you lose one burner, it's not that big a deal, but you don't want to lose your entire top. Next slide, please. As Richard said earlier, all electric kitchens aren't necessarily all induction kitchens. There are wonderful options for electric and Lee was talking about as well that you can use and that can all be integrated together. Next slide. I guess that's it. Thank you. If you're still awake, I appreciate. I apologize for the video fun, but I hope you all enjoyed it. If you have any questions, please feel free to ask. Thank you so very much.
Thank you, Kurt. Very interesting. I really appreciate your presentation. And I have an induction stovetop that I absolutely love. I just can't say enough positive things about it. So thank you. And then next up, we have Michael Slater. Please, Michael, talk to us about hot water heating in commercial.
Yeah,
kitchens.
happy to do it. My name is Michael Slater. I'm a professional engineer with the Food Service Technology Center. I'm one of Richard's colleagues. And one of the great things about induction is that it replaces a technology where the gas piece has a thermal efficiency around like 35%, and you get a big, jump to 85, 90%. As Kurt was saying, that really helps the economics of doing a 1-for-1 replacement workout because you make up for the increased cost of fuel because electricity is generally more expensive than gas by making up some pretty significant energy savings. The big problem with water heating is that the baseline technology, just a standard efficiency tank type water heater, like the same thing that everybody has in their garage, that has a thermal efficiency that's about 80%. So using conventional electric technologies to replace gas technologies, you don't wind up getting the same kind of energy savings for the run because we have like 10 minutes left here. And this is a fairly complicated sort of subject. So I'm going to do my best to sort of distill everything. But, as Richard was saying, all of our resources are on the California Energy Wise website. And so if I miss something or if you want to dive deeper, there's a lot of stuff there. But recently we put together a new design guide for hot water systems for commercial food service. That's up there. The technical design guide is sort of a distillation of maybe the last like 20 or 30 years of going out into the field, putting water and energy meters on water heaters and trying to figure out how to make better water heating systems. So in commercial food service, we care about hot water systems because you can't have a restaurant without hot water. You need hot water to wash your hands. You need hot water to wash your dishes and your equipment. You need hot water sometimes to cook food. And these are all areas that local health departments have jurisdiction over. So if you don't have hot water in your restaurant, you can't keep everything safe and sanitary for everybody. The health department will shut you down, right? Sorry, I'm having some trouble advancing here. We also care about hot water systems because they're highly energy intensive. The hot water systems in California's commercial food service facilities total about 340 megatherms per year, which accounts for about 16% of gas usage in all commercial buildings in the state. So it's a pretty significant load in general. And that means that electrifying the entire system is going to be a big push. It will be a significant issue. Generally, there are 3 parts of a hot water system where you have hot water delivery. So that's all of your fixtures, your sinks, your dishwashers, pre-rinse spray valves. You have distribution systems, which is the piping that brings water to all of your fixtures. And then you have your hot water generation, basically your water heater or set of water heaters to make the water hot, right? And there are significant energy savings available for replacing parts of hot water systems in all of these areas. This presentation will focus mostly on the water heaters, but you can get, similar to Richard's point, that energy efficiency is the most important part of building decarbonization. Getting the efficiency and hot water savings from fixtures and distribution systems are actually more cost effective usually than just going and straight up trying to get more efficiency out of your water heater itself. Oh, all right, it wouldn't go and then it went. Sorry. I included this slide. This is from a study that we did where we monitored every part of a full service restaurant's hot water system and counted all of the water use at each fixture, just individually with water meters on each fixture. And I wanted to include this to point out a couple of things. So one, the dish machine here uses about half of the hot water for this full service restaurant, and that's a fairly common thing. And also we're talking about hot water systems that use on the order of like 1,000 or so gallons of hot water per day. So you can see on the axis on the left, the hot water usage is up to 400. The big purple bar in the middle is almost up to 400. Multiply that by 2, you've got 800 gallons per day at this full service restaurant. Getting hot water savings at any of these fixtures will give you some significant energy savings for your entire system. And this is from a design example that we put together for a quick service restaurant to just look at cost impacts of using different water heaters in quick service restaurants. We have our sort of standard gas-fired water heater all the way on the left, and then we have sorry, I'm trying to draw on this and this is not working out super well, so I'm going to do my best to just speak over it. One of the big problems with just using an electric resistance water heater, which is the analog to a standard gas-fired water heater, it's the 4th column on this table, is that it essentially doubles your 10-year utility cost. And so you need to use a heat pump water heater to make up some of the energy savings for going from a standard efficiency gas-fired water heater to an electric water heater to be able to have any kind of reasonable economics from this. You can see in the 5th column that the 10-year cost is, the percentage increase in 10-year cost at the bottom, the 5th column over, is 18.5%, and the last column is 4.7%, meaning that those systems are effectively 18.5 and 4.7% more expensive in the long run to run than your standard gas-fired water heater system, but your electric resistance water heating system is 108.1% more expensive to run than your standard gas-fired water heater. The reason that heat pump water heaters are so important is because you get to operate them with a coefficient of performance. People who know a bit about refrigeration know that a coefficient of performance is an analog to energy efficiency. Heat pump water heaters of this size typically have operating coefficients of performance around 3.5, which effectively translates into 350% thermal efficiency, right? A standard electric just resistance water heater has in a thermal efficiency around 95%, which means that the heat pump water heater is effectively 3.5 times as efficient as standard electric water heaters. Part of the reason that people have not been able to do this effectively is that heat pump water heaters require a larger footprint and they have a slower hot water recovery. Effectively, they can't generate hot water as quickly as either standard electric or gas water heaters. And that's a big problem in commercial food service because you have fixtures that are using huge amounts of water during basically all times of the day. So you're always taxing your water heater, drawing everything out of it and asking it to basically refill itself with more hot water. And so if you have slow recharge rates, you'll eventually drain your water heater and not be able to adequately deliver hot water to critical sanitation fixtures. Heat pump water heaters are essentially a refrigerator. So they suck heat from the ambient air where they're installed through an evaporator. That heat gets piped through a compressor, and then this condenser is essentially submerged in a tank of water. If you were to take your refrigerator at home and took the hot coil on the back of it and submerged it in a tank of water, you have just built a heat pump water heater effectively. Electric heat pump water heaters usually have a backup electric resistance unit. That's something that is implemented kind of to deal with the slow recharge rate problem. Couple more design constraints for heat pump water heaters. They're a little noisy. There's some concern over what refrigerants they use, but modern ones are being built with low GWP refrigerants. They require ventilation, which is an important thing. It means if you install a heat pump water heater in a small enough room, you're going to turn that room into a walk-in fridge. So you need to be able to replace that air to basically keep feeding your heat pump water heater with the ambient heat that it needs. One of the big problems for heat pump water heaters, and actually really for any kind of building decarbonization, is that it may require a panel upgrade or a service entrance upgrade for one-to-one retrofits. There was a question about that in the chat that basically asked to speak to the economics of doing service entrance upgrades and upgrading your facility's infrastructure. That's kind of the big question mark with decarbonization in general. It depends on a couple of factors. One of them is just how much electric capacity do you have left on your system? What are the size of your wires and how much amperage can they handle? What's the current size of your service entrance? And, what's the size of your new load? Those are all things that have, big impacts on the cost of a retrofit. And, as people are starting to decarbonize, especially in commercial kitchens that have very large loads, that's going to be a pertinent question going forward for sure. The biggest constraint and the biggest reason that heat pump water heaters haven't really hit the market yet is that they need to use the California Department of Environmental Health sizing guidelines. I don't have too much time left, but the CEDA sizing guidelines basically make you oversize your water heaters. The issues with the traditional sizing is that they lead to way oversized water heaters and way oversized distribution systems, which leads to energy waste. And a pertinent problem for heat pump water heaters is that if you way oversize your heat pump, it'll never realize its full COP, and you'll be operating it, mostly in its electric resistance mode, which will, drive the cost of your system. The bottom line is that replacing the current stock of natural gas water heaters with conventional electric water heaters is going to make your favorite restaurant go broke. The economics of it aren't going to work. And as Richard said in the beginning of this presentation, restaurants are so strapped for cash that, making changes to making these significant increases in their utility bills is, going to hurt them badly. Because of their high efficiency, heat pump water heaters offer a financially feasible solution to decarbonizing hot water systems in commercial food service. But we need to resolve our hot water system sizing issues, address some health department concerns, and field test this emerging technology before moving forward with a statewide replacement. This is a link to a survey to basically request, what kind of information you want to see in future presentations. I'll also drop a a link in the chat. And with that, I'll turn it back to Susan. Thank you very much.
Also helps in terms of the amperage and voltage.
Right.
Yeah.
Michael, have you seen, are there any of these combined heat pump electric resistance water heaters in restaurants that y'all have seen, or is it still nascent enough that there aren't any pilots in process yet?
We're running a field monitoring pilot in a full service restaurant right now, where we're going to install a heat pump water heater. There are very, very few. There are a handful that are in San Francisco, but yeah, I mean, nascent's a good word. It's, there are a lot of significant barriers to installing heat pump water heaters. I mean, one thing I didn't mention from the sizing guidelines is that the health department essentially makes you size your heat pump water heater as though it is an electric resistance water heater. They don't let you take advantage of your COP for sizing, which means that you wind up with a heat pump water heater that's like 3 or 4 times the size that you need, which ends up being totally cost prohibitive.
I just have a quick question, Kurt. I hope it's okay that I ask. I know that the commercial kitchen space for Microsoft, that the induction wok video you showed was fairly large. I think it was 7,000 square feet. Is there another commercial kitchen kind of in progress for another Microsoft campus that's even bigger? That was something that I saw might be happening.
Yeah, that was actually only one phase. Astera was the first phase, and it was actually completed first. There are probably the largest preparatory or preparation kitchen in the world, I think, that's electric, is also on Microsoft's campus. It's now opened up. There are probably another 4 or 5 operations the size of Astera that are operating right now on Microsoft's campus or are being started in Microsoft campus. And there are a lot of other spots where this type of stuff is happening. Some of our high-tech companies are moving the same direction. As I said, it's possible. I think most of it is brand new build or people who have the wherewithal to make that happen. But yes, and there's more coming. There's much more coming. We have a number of projects right now that will be on Microsoft scale, or at least Microsoft single store sale will dwarf the first one, not all 5 or 6 together, but yes.
Thank you for that. I just might ask a question here in our Q&A section, asking if any of you have come across how the IRA's tax incentives and or bill financing might impact costs of restaurant electrification.
That's a really good question that we have not really bumped into. And I would suggest people follow it up. I know in the past there were some abilities to get tax credits and bundle things, and it really required working with an accountant and a tax specialist. And there was a chance back in the day when we were all moving over to LED lighting. If you had chains, you could bundle all this stuff up and actually get some tax credits. So can't answer that one. What I can answer is to just tell you that the very first place to go look is for utility incentives. That's the most fast and direct place. And like I mentioned before, there are instant rebates in California, but they're also in another, dozen states across the United States. So that helps to buy. And somebody had also asked questions about capital cost. And like I mentioned in my slides, yeah, this more effective equipment, it's higher end, it's programmable, you get a lot of benefits, but there's a higher capital cost out of that. It's like I paid more for my electric vehicle, right? But those rebates are meant to help bridge that gap to the more efficient equipment, both gas and electric. So take advantage of those incentive programs, because the beautiful thing about that is the more that operators take advantage of the incentive programs, the more the utilities say, wow, these incentives are working, we'll keep the programs going. If you blow the rebates off, the utilities go like, well, nobody cared, and they'll cut them off. So take advantage of those. It feeds the pipeline, and it is a really direct way to help operators out.
Yeah, good points. Thank you for that. And then I might combine the next couple of questions, Michael. They're for you. Could you point to the code that leads to oversizing of water heaters? And then second to that, are you seeing any policy movement on that sizing issue?
There is some policy movement. We've been working with the Bay Area chapter of the CEDH. And people are basically interested, health department officials are basically interested in seeing how well heat pump water heaters can work in commercial food service. At the end of the day, they want to see adequate hot water delivery more than they really care about the actual like energy economics of it. And so the results of some of the pilots that we're working on now are going to wind up being pretty critical in influencing policy in the future. I can pull up the sizing guidelines that the health department uses and link them in the chat. I'll work on that in the background.
Yeah. And by the way, there's a bunch of people working on this. San Francisco Department of the Environment, TRC is working with Michael, PG&E is running codes and standards work on this. A lot of people see this as a crucial item. So the very first thing that will happen is you'll see some training from us later this summer that Michael and I will do. We'll each do a class. I'll do like the 101. Michael will do the 201. They're really going to be focused on environmental health people and allowing them to know what to do right now today, because it takes a little while to change an environmental health code. You know, we're going to have to build case studies and make a case, right? But right now, today, there are some things that people can do as they walk in that would allow them to say, hey, we can put a heat pump water heater in here, here's why. Barry at the city of SF just released a draft guideline. We're going to roll that into our training. So there is a lot of movement and a lot of hope, but that is a huge challenge at the moment. Is we have seen environmental health departments say, nope, can't put a heat pump water heater in here because of a lack of knowledge and training. So we're working on that one.
Susan, I had a quick question maybe. I'm wondering, in the residential electrification space, you know, a lot of times we say, create your roadmap, plan your changes over time. In the code, does that apply to the commercial kitchen electrification space? I mean, is a restaurant owner, you know, who's got so many concerns, and we saw in the chat that so many restaurants go out of business in the first 5 years. How do you make it bite-sized? How do you chunkify these changes? What do y'all recommend?
Yeah. So we did a study a few years back where we changed out a traditional convection oven and actually dropped a small rational combination oven into a traditional cook line. And it actually shrunk the cook line down and this was at a bar down in San Diego. Great case study. And it gave the cook line a lot more flexibility and actually reduced their space a little bit. So absolutely, you know, if a piece of equipment goes out, try a new piece of equipment. I was also asked by a hotel chain that has a bunch of franchisees, like, how do we start this? You know, if we walk into the franchisees and tell them they got to gut their whole cook line, they'll come after us with pitchforks. And in that case, I said, we'll start with an induction cooktop. If you got panel space, you know, drop in a full-on commercial induction cooktop, because you get the visual aspect. You can walk people over and say, hey, look at this unit. Plus you get to try it out. Plus you get the benefits of reduced heat. That's a regular cooktop is a pretty big heat generator into the kitchen. So absolutely try little things and move forward in that way. I mean, in some ways that's already happening as people are adding more service into smaller spaces with things like rapid cook ovens. Those high-speed ovens that you've seen in a Subway or a Starbucks, people are already experimenting with that. So that makes a lot of sense.
All right, and I think at that point, it might be good for us to say farewell. We're at 11:15. Thank you to all of you for joining us, and to those of you who could stay a little bit longer with us for some more conversation, and to our panelists. We appreciate you so much. Thank you again for your leadership, and we look forward to talking to you all again sometime in the near future.
Great.
Take care.
Thank you so much.
you.
Cheers.
Bye-bye.
Thanks, everybody.
Bye.
Please ask for